Question 19. The database administration team has asked you to help them improve the performance of their new database server running on Google Compute Engine. The database is for importing and normalizing their performance statistics and is built with MySQL running on Debian Linux. They have an N1 standard 8 virtual machine with 80 GB of SSD persistent disk. What should they change to get better performance from this system? A. Increase the virtual machine's memory to 64 GB. B. Create a new virtual machine running PostgreSQL. C. Dynamically resize the SSD persistent disk to 500 GB. D. Migrate their performance metrics warehouse to BigQuery. E. Modify all of their batch jobs to use bulk inserts into the database. The best option is C. Dynamically resize the SSD persistent disk to 500 GB. Key considerations. 1. Google persistent disk performance. The performance of SSD persistent disk scales with the disk size. For disks smaller than 1 TB, performance is proportional to the size of the disk. Increasing the size of the persistent disk from 80 GB to 500 GB will improve both IOPS, input-output operations per second, and throughput. 2. Database workload characteristics. Databases like MySQL are often limited by disk performance, especially for write-heavy operations such as importing and normalizing data. 3. Dynamic resizing. Persistent disks on Google Compute Engine can be resized dynamically without downtime, making this a simple and non-disruptive improvement. Analysis of options. A. Increase the virtual machine's memory to 64 GB. Adding more memory can help performance if the database is memory constrained, but the N1 standard 8 VM already has 30 GB of RAM. Disk performance is a more likely bottleneck here. B. Create a new virtual machine running PostgreSQL. Changing the database engine introduces significant operational and compatibility challenges. This option doesn't directly address the current performance bottleneck. C. Dynamically resize the SSD persistent disk to 500 GB. Correct solution. This directly increases disk performance by providing higher IOPS and throughput, addressing a likely bottleneck. D. Migrate their performance metrics warehouse to BigQuery. BigQuery is excellent for analytical queries but is not designed for OLTP, online transaction processing, use cases like batch imports and normalization. E. Modify all of their batch jobs to use bulk inserts into the database. Bulk inserts can improve write performance, but they require significant application changes. Disk performance improvement is a more immediate solution. Why resize the disk? Scalability. SSD performance scales with size. Non-disruptive. Resizing persistent disks can be done while the VM is running. Cost-effective. Adding disk size is simpler and cheaper than increasing VM memory or switching to a new database. Correct answer. C. Dynamically resize the SSD persistent disk to 500 GB. This solution optimizes disk performance, directly addressing the database's likely bottleneck, with minimal disruption and cost.